Okay, so here is an overview of what we should be looking at this week. First, the beginning is an introduction and it has some slides and there's a video. And really importantly, what this first part is about doing gas stoichiometry problems. And these first three links have videos walking through how to do those problems, which you can take a look at. However, let me also go ahead and open this up. And what we can do is work on a problem or two right now. And so this is something that I think Mr. Okay, this is from our workbook. Let me see if my writing works here. Let me just download this. All right, let me give some introduction and then we'll quickly go to how to do some of these problems. The key thing that you need to know here is that for every 1 mole, let me get to, well, let me just highlight it. For every 1 mole of gas, you have 22.4 liters. And so in all of these problems, if you have 1 mole of gas, the volume that will occupy is 22.4 liters. And so 1 mole is a number of particles. So we have a certain number of particles, and we know that at standard temperature and pressure, which is basically like at sea level with 0 degrees Celsius, at that temperature and at that pressure, we know that 1 mole of an ideal gas will occupy 22.4 liters. And so in these questions, they use that information when gases are produced in reactions. For example, it says at STP, how many liters of chlorine gas are needed to produce 10 grams of NaCl? Well, here we have NaI plus chlorine gas makes NaCl and I2. And we know that we want to make 10 grams of NaCl. And we want to go backwards to see how much chlorine gas is needed. And we can figure that out in moles, and we can also figure that out in volume after we get moles. I'm going to try one more time to write directly on this. Let's see here. I figured this out the other day. This is let me just rant for a second. This is Adobe Acrobat, which if back in the day, they were like the first people to do PDF documents. And this is their editor. And it really sucks. This is like the worst program in the whole wide world. I hate this program. I can't even write on this document. Okay. What I'm going to do is I'm going to, let's see here.
Dr. Wu, you're using Windows, right?
Yeah.
If you right click on your toolbar, which is on
Yeah.
the bottom,
Yeah. Down.
and you click to allow Windows Ink Workspace, you can write directly on the screen.
Down to the bottom right, are you saying, or on the?
On the left, directly to the right of the Adobe Acrobat app on your screen. Yeah, right click to the right of that, just a little bit more. Right click there. Then you see the option Show Windows Ink Workspace button.
Show Windows Ink Workspace button. Boom. Richard, I'm going to give you some Warrior Dollars, which, by the way, you can come at the beginning of next year and redeem. Just remind me. I'll add it at the end of the call. Nice work. Okay, let's see here. Screen sketch. So we're going to start with 10.0 grams of NaCl, and then we need to go backwards to see how much chlorine gas is needed. So we're going to convert from grams to moles. And we know, and you guys can help me by looking this up while I'm doing this. I have a computer here, but if you know it, let me know. For every 58.44 grams, we have 1 mole of NaCl. And I know for every 2 moles of NaCl, I need 1 mole of chlorine gas, Cl2. And the last step, which is kind of new, is I go for every 1 mole of Cl2 gas, I know that that is 22.4 liters. And so if I were to calculate this out by multiplying the tops and by dividing the bottoms, I would get a certain number of liters of chlorine gas. And that liters of chlorine gas, that volume, is what is required to produce 10 grams of NaCl. Don't hesitate to ask a question and stop me if you have one. Don't forget that this is all at standard temperature and pressure. All of these questions here have to do with using that 22.4 liters to 1 mole conversion. And these videos will also focus on that. So basically that's these 3. If we go to the graded assignment, here you have a practice quiz and then there's a quiz walkthrough. What you're going to see is, for example, let me just give you some tips on this first one. Oh, oops. Well, the walkthrough has the practice. The walkthrough has the answers. So anyways, it says, using the reaction below, calculate what mass of lithium that's here is needed to produce 5.2 liters of hydrogen gas at STP. We want to make 5.2 liters of hydrogen gas. And we want to know, how many grams of lithium is that? Well, I'm just going to start with 5.2 liters of H2 gas. This is what I want to make. And now liters is going to go on the bottom. And I know that for every 22.4 liters, I have 1 mole of hydrogen gas at standard temperature and pressure. So I will convert to moles of hydrogen, and then I will go from moles of hydrogen to moles of lithium. And then I will go from moles of lithium to grams of lithium. Again, more information on that is available in the walkthrough. I'm going to continue summarizing this lesson, and then take any questions. Gas stoichiometry 1 quiz is much of the same. Before I move on to the ideal gas law, any questions about gas stoich STP? All right, let's take a look at the second part, the ideal gas law. We have two videos here that introduce the ideal gas law, one by Tyler DeWitt, one by Mr. Lose. And they both, this one has some notes, guided notes you can go with it. The second one has some practice problems that you can follow along with. Either is good, both of them is also good, or neither if you feel like you just want to jump straight to the practice problems. How do these practice problems work? Well, there are some videos that walk through the practice problems, but there's really two types of practice problems. One is like what you'll find with this Science Geek ideal gas practice. Now notice that it doesn't really pop up for me, so I'm going to click this button to help it pop out. All of these questions, and this is one quiz that you'll see, use the equation PV equals nRT. And so let's try one together. It says a gas system has pressure, volume, and moles of 1.31 atm, 8.02 liters, and 0.535 moles. What is the temperature in degrees Celsius? Well, I see that I have all of these variables in PervNet. And so I'm going to plug them in to this equation. Now I ultimately want to get temperature. So if I rearrange this equation, I can get temperature equals PV divided by nR. Once again, I see that I'm missing some of these variables and I want to solve for one. I can use the PervNet equation, and I want temperature, so I can rearrange it to have T equals PV divided by nR. I did that by dividing both sides by nR. Now that I have my equation in the right format, all I have to do is plug in. I have 1.31 atm for pressure. I have 8.02 liters for volume. For number of moles, I 0.35. And then I need to plug in R. R is the ideal gas constant. And it is based on, there's different units for the ideal gas constant. And we need to take a look at what units, specifically pressure, we're dealing with in order to choose the right ideal constant. What you're going to see is that, and let me see here. So I see that the ideal gas constant for atmospheres, what I have is 0.0, so R equals 0.08257. And the units for this are liters times atm divided by moles divided by Kelvin. And so I'm going to plug this number in here because it matches my units. I have liters, atmosphere, moles, and it will give me temperature in Kelvin. If I plug this into the calculator, what I'm going to plug in is 1.31 times 8.02 divided by 0.535 divided by 0.08257. And that gives me temperature equals 239. This problem, the smallest number of significant figures is 3, so I'm going to leave it as 3 significant figures. Who can tell me what unit my temperature is in currently?
Kelvin.
It's in Kelvin. That's absolutely positively 100% correct, Richard. And so this is Kelvin. How did I know that? Well, because my units of R have Kelvin, my final answer is in Kelvin. And if you notice here, my units would cancel out in such a way where Kelvin is on top for my temperature. Moles will cancel out, liters and atmosphere will cancel out, leaving Kelvin. But they want my temperature in degrees Celsius. Well, for that, we just need to remember the conversion for Kelvin to Celsius. And don't forget that Kelvin is an absolute temperature scale, and basically it is to accommodate for what's known as absolute zero. And so we know that our temperature in, let's say we want degrees Celsius, well, it's Kelvin minus 273.15 equals my temperature in Celsius. So if I want degrees Celsius, I plug in my temperature in Kelvin right here. So 239 minus 273.15 gives me negative 34.15 degrees Celsius. The smallest, again, this is only 3 significant figures, so let's just go ahead and do negative 34.2 degrees Celsius. And also keep in mind that this is a reasonable number. Negative 34 degrees Celsius, that sounds pretty reasonable. Let's see here. Negative 34.2, check answer. It says incorrect. There were some issues that people were having with this giving correct answers or not. Let's do show answer. They got something very close, and it may have to do with, so it looks like it has to do with significant figures. I got negative 34.2. They got negative 34.00. And, oh, maybe did I put my negative in the wrong spot? Okay, so point is, if it comes up incorrect, it's okay. If it's close enough, you can check show answer. All right. Oh, by the way, if you do this and it's incorrect, I mean, on a quiz or something, you would not get that kind of feedback. But if I were doing this, I would check to see, number one, all my units were what I expected. Sometimes you're getting your units incorrectly would be enough to throw off your calculations. Now, finally, that's one type of problem that you're going to see. There's one other type of problem that you'll see in the quizzes, and this is also what you'll see in the quiz at the end. Let me briefly just go over this. Let's take a look. It says a 500 milliliter metal cylinder holding 1.00 moles of helium gas is known to rupture at a pressure of 10 atmospheres, at what temperature in degrees Celsius will the container fail? This is a PV equals nRT question, and you're solving for temperature, and they want it in degrees Celsius. You would need to convert the volume of 500 milliliters to liters, plug in to, this would be V, this would be N, and let me just remind you, this would be V, this would be N, this would be P. We have R, you look that up, and remember it's based on your pressure per unit. You're going to get T, it will be in Kelvin, and then you convert to degrees Celsius. That's very similar to what we saw on the last question. Let me just skip to the quiz here because I think there's slightly different kind of question that you're going to see, but maybe not. Actually, I don't think so. Yeah, all of these right here, all of this stuff right here is all plugging in and solving for PV equals nRT. And all of this stuff right here in this first quiz is basically making sure you understand the units. Any questions on either of those? And or anything you want me to show you one more time? This is something I wrote up myself, and it has to do with figuring out whether or not you have the coronavirus, even if you don't show symptoms. And it uses some research that has been put out recently. And so it's to help us to think about science and help us to think about whether or not you have the coronavirus. I highly recommend that you partake and take a look at that. It's optional, but you'll get bonus points. Now let me pause the